the quantum Grover's algorithm. Grover's search algorithm in quantum computing gives an optimal, quadratic speedup in the search for a single object in a large unsorted database. It can be generalized in a Hilbert space framework for both continuous and discrete time cases. As shown in, Grover's algorithm initializes the search space by creating an equal superposition of nputs vertical bar phi1 in, the superscript denotes nputs, by applying the Hadamard transform H. Then it applies the function fx, the oracle, that is equivalent to a gate operator called the C gate. This function is given by where vertical bar xr is the required search result. The C operator will reverse the sign of the state, rotate by phi1 that most represents the required search result. This argument will be used later in defining the oracle function used in our proposed implementation and leave all other states unchanged. Block diagram of one-stage basic Grover's algorithm. After applying C, the result is flipped around the mean by the H and P operators. H is the Hadamard gate and P is the controlled phase shift operator gate, which for arbitrary phi1 and phi2 is given by. Then in matrix form we can see that where the superscript denotes that it is an NX operator. Applying the Grover's gate, G, times to find the final search result, where we see that is paths the searching order own paths. Next we discuss the use of Grover's algorithm for implementing Viterbi algorithm. Implementation of VA using Grover's search algorithm. Viterbi decoder searches all possible branches at each signaling interval in the code tree. This requires storage of all paths including the survivor path, computation of each branch metric and a decision making to select the survivor path. In quantum theory the components are somehow different. We have a register containing a certain number of qubits, an arbitrary transformation applied on these qubits and a measuring mechanism that measures the state of each particular qubit. The quantum VA can be viewed as a global search in all the possible paths in the decoding trellis. This means that for a classical convolutional code fault with n, k, m parameters, signaling symbols and the number of trellis states is 2 meters, from equation 7, we see that the total number of possible paths is int equals L to m plus k. When using the Virginia we propose a single search quantum Viterbi algorithm, SQV, and a multi-search quantum Viterbi algorithm, MSQV.